So in these questions we have to find the resistance across A and B, and this question is very similar to bit of last two questions. So we'll solve it. We have to find resistance between across A and B, and we had two rules in first lecture, that stick to this terminal and start from the end of network. So we'll stick to this terminal, and we don't have end of this network, we don't have end part of this network, so we'll solve it randomly. And here is a key concept is that we have to solve you have to modify the circuit, you have to simplify the circuit, and then we will be able to solve this circuit. So for simplification I told you that just give the name to the nodes, this A and this A, and now this node is connected to this R. So now this node and this node is not same, so we can't call it that this node is connected to to here and this node is same. No, this node is not same because it is connected to through R. So we can call it as C, another node. Okay, now this node is also connected to through R. So now here also we can't call this node and this node is same, so we'll call it D, right? So now simplify the circuit. Now to redraw the circuit, just assume that this is A node, this is between A and D. Assume that between A and D there is one resistance, we call it R. Between A and C there is one more resistance. So where is a C node? We'll just take C node here. Between A node and C node there is a resistance. So this resistance is also gone. And between D and C there is one more resistance. Between D and C, right? This resistor also gone. Between C and B there is one resistor. Between C and B, where is B node? We'll just redraw here. C and B resistor. This resistor is gone. Between B and D there is one resistor. B and D. So these are resistors. So now we have to calculate resistance across A terminal, between A terminal and B terminal. This is A terminal, this is A terminal, this is B terminal. So you are able to see that this is the Wheatstone bridge. So we can So we can forget about this resistance between this resistance, and we can simplify it like this. Because this R in series, this also R in series, because we open circuit it and B. So what is equivalent resistance is R. So what is the concept of Wheatstone bridge now? Because this node and this node is at the same potential, so there is no current flow in between this resistor. So we can neglect this resistor, or we can short circuit it, or we can open circuit it. So it's up to you. Whatever we did open circuit, if you do short circuit also, this C and D will connect it like this R and this R, and now we connected C and D, and now again we have R and R. So here is the same node. So this is in parallel, this is in parallel, R by 2. It's equivalent R. And one more method is there. You can convert this delta into equivalent star. Then also you will get same answer. So I think you should go with this Wheatstone bridge approach. That is used widely used, and you can simplify it by Wheatstone bridge technique. So you can solve it very properly and very quickly.